12th problem. A magnet vibrates in a magnetic field of strength 10 power minus 4 Tesla. If the magnetic moment of the magnet is 10 power minus 1 ampere meter square and moment of inertia about the axis of rotation is given as 10 power minus 5 kg per meter square, you are asked to calculate the time period of oscillation of the magnet. Time period of oscillation. According to the formula for a time period of oscillation for a magnet by using vibration magnetometer, the formula is T is equal to 2 pi under root I by m into B, given moment of inertia about the axis of rotation of the magnet. So, you are asked to calculate the time period of oscillation of the magnet. The time period of oscillation of a magnet can be calculated by using a vibration magnetometer. The relation is T is equal to 2 pi under root I by mbh, given I moment of inertia as 10 power minus 5 kg meter square. The magnetic induction of the magnet is given as 10 power minus 4 Tesla. The magnetic moment of the magnet is also given as 10 power minus 1 ampere meter square. You are asked to calculate the time period of oscillation of the magnet. So, substitute that data in this relation, we get a T is equal to 2 pi under root 10 power minus 5 by 10 power minus 1 into 10 power minus 4. All these terms gets cancels. You will get the time period of oscillation of the magnet as 2 pi seconds. So, the option third one is correct. Problem number 13. Find the force between two similar magnetic poles of strengths 10 ampere meter and 20 ampere meter which are separated by distance 10 centimeters. The given options are 2 10 power minus 1 newtons, 2 10 power minus 2 newtons, 2 10 power minus 3 newtons and 2 10 power minus 4 newtons. This is the problem based on the concept of Coulomb's inverse square law. According to Coulomb's inverse square law, the force of attraction or repulsion between any two magnetic poles is F is equal to mu naught by 4 pi m1 m2 by d square. Here given the magnetic pole strengths m1 as 10 ampere meter, m2 is given as 20 ampere meter. The distance between the two magnetic poles is 10 centimeters, which is equal to 10 power minus 9 meters. You are asked to calculate the force. So, the force F is equal to mu naught, whose value is 4 pi 10 power minus 7 by 4 pi into m1 into m2, 10 into 20 by d square, which is 10 power minus 1 whole square. When you simplify this, you will get the force as 2 into 10 power minus 3 newtons. So, the third option is correct one. 14th one. The frequency of oscillations of a bar magnet at a place is 0.1 hertz, where the Earth's magnetic field induction is B. You are asked to calculate the frequency where the magnetic induction would be 2B. The given options are root 2 hertz, 2 hertz, 1.414 hertz and root 3 hertz. So, this is the problem based on the concept of the time period of a magnet in vibration magnetometer. The formula is 2 pi under root I by m into B. This is the formula for time period, but frequency of oscillation. We know that frequency of oscillation is the reciprocal of time period. If you take the reciprocal of this, we get 1 by 2 pi under root m into B by I Here I is moment of inertia. Now take the relation between frequency and magnetic induction. According to that relation, the frequency and magnetic induction, they both are related as frequency directly proportional to square root of magnetic induction. Applying square on both sides, n square directly proportional to b. From this, n1 square by n2 square is equal to b1 by b2. Given the frequency of oscillation n1 as 0.1 hertz, where the electromagnetic field is B, that is B1 is equal to B. You are asked to calculate the frequency of oscillation N2. You are asked to calculate where B2 is 2B according to the given data. Now substitute that data in this relation. N1 square by N2 square, that is 0.1 whole square by N2 square is equal to B1 by B2, B by 2B. When you simplify this, we get the value of N2 as 1.414 hertz. So the third option is correct one. Next, 15th one. Two similar and equal poles repulse with a force 10 power minus 3 newtons when separated by distance 1 meter. You are asked to calculate the pole strength of each pole. The options are 10 ampere meter, 100 ampere meter, 1000 ampere meter and 1 ampere meter. This problem is based on the concept of Coulomb's inverse square law, according to which the force of attraction repulsion between two magnetic poles is mu naught by 4 pi m1 m2 by d square. According to the given data, two similar and equal magnetic poles, he said, given m1 is equal to m2 is equal to m. I am supposing the force is given as 10 power minus 3 newtons. They are separated by distance 1 meter. So distance is also given as 1 meter. You are asked to calculate the pole strength of each magnetic pole. When you substitute this data in this relation, we get force 10 power minus 3 is equal to mu naught value 4 pi 10 power minus 7 by 4 pi m into m, that is m square, by distance is 1 meter. So here it is m square is equal to, when you transfer 10 power minus 7 to other side, it becomes 10 power plus 7. So it becomes 10 power minus 4. From this, m is equal to 10 power 2. That is the magnetic pole strength of each. The pole strength of each pole is 100 ampere meter. So second option is correct one. 16th one. The force experienced by each pole of a magnet kept in a magnetic field of strength 4 10 power minus 5 Tesla is 8 10 power minus 4 newtons. Find the magnetic moment of the magnet if its length is 10 centimeters. The given options are 1 ampere meter square, 2 ampere meter square, 3 ampere meter square and 4 ampere meter square. Given force as 8 10 power minus 4 Tesla, the magnetic field strength B is given as 10 power 4 10 power minus, this is newtons, 4 10 power minus 5 Tesla. The magnetic length 2L is given as 10 centimeters. You are asked to calculate magnetic moment of the magnet. See, what is the formula for force experienced by a magnetic pole which is kept in the uniform magnetic field, F is equal to mb. From this, first calculate the pole strength of the magnet. Pole strength M is equal to F by B. Given the force as 8 10 power minus 4 by B is given as 4 10 power minus 5. So it goes 2 times. It is 2 into 10 power 1, that is 200 newtons. For 200, this is magnetic pole strength, no? Ampere meter. You are asked to calculate magnetic moment. We know that magnetic moment is the product of pole strength and magnetic length. Pole strength we got it as 200 and the length of the magnet is given as 10 centimeters, which is equivalent to 10 power minus 1 meter. So it becomes, we got the answer as 2 ampere meter square. So the second option is correct one. Problem number 17. A magnet of moment 80 ampere meter square is placed in a magnetic field of induction 1.8 10 power minus 5 Tesla. Find the length of the magnet if each pole experiences a force 75 10 power minus 4 newtons. The given options are 0.192 meters, 0.362 meters, 0.262 meters and 0.292 meters. So according to the concept of force experienced by a magnet which is placed in the magnetic field is F is equal to mb. This from this F is equal to, in place of magnetic pole strength, one thing, since magnetic moment is the product of length into pole strength, from this pole strength is equal to magnetic moment by length of the magnet, because according to the given data the magnetic moment and length are given. So given magnetic moment as 80 ampere meter square, the magnetic induction is given as 1.8 10 power minus 5 Tesla. Find the length you are asked to calculate. The force is given as 75 10 power minus 4 newtons. Now look at this relation. F is equal to, in place of small m I am writing m by 2L into magnetic induction. You are asked to calculate length of the magnet. So take out 2L from that, it becomes m into b by f. Now substitute the values. From this 2L is equal to, m is given as 80, induction B is given as 1.8 10 power minus 5 by the force as 75 10 power minus 4. If you simplify, you will get the magnetic length as 0.192 meters. So first option is correct one. Next problem. A magnetic dipole of a moment 0.3 ampere meter square is suspended in a uniform magnetic field of induction 0.2 Tesla. The dipole axis makes an angle 30 degrees with the magnetic field. You are asked to calculate the torque acting on the magnet. The given options are 0.02 Newton meter, 0.04 Newton meters, 0.03 Newton meter and none. So according to the data given the magnetic moment of the magnet as 0.3 ampere meter square. The magnetic field induction is given as 0.2 Tesla. The axis of the dipole makes an angle 30 degrees with the magnetic field. You are asked to calculate the torque acting on the coil. The formula for torque acting on a coil that is placed in a magnetic field is tau is equal to mb sin theta. That is, m is given as 0.3, induction is given as 0.2 into sin 30, that is 0.3 into 0.2, the value of sin 30 is 1 by 2. If you simplify, you will get it as 0.03 Newton meters. So, the third option is correct one. Next problem, given two north poles of the pole strengths 10 ampere meter and 40 ampere meter are separated by a distance 20 centimeters. You are asked to calculate the point where the resultant magnetic field due to both the poles is 0. The given options are, first one 0.011 meters, second option 0.012 meters, third option 0.013 meters, and the fourth option 0.014 meters. Now, two magnets of pole strengths 10 ampere meter and 40 ampere meter. Let us suppose this is the first pole of pole strength M, second pole of pole strength M2. Let M1 is 40 ampere meter, M2 is 10 ampere meter. According to the given data, the distance between both the poles strengths is given as 20 centimeter. You are asked to calculate the point where the resultant magnetic field due to both the poles is 0. Let us suppose that this is the point P where the resultant magnetic field due to both the poles is 0. I am supposing that this distance of this point from the second pole of pole strength 10 ampere meter is x, then the distance of this point from this first pole of pole strength, it would be 20 minus x, because the actual distance between both the poles is 20 centimeters according to the given data. So, what is the formula for magnetic induction due to pole? B is equal to mu naught by 4 pi m by d square. Now, the magnetic induction at point P due to first pole and the magnetic induction at point P due to second pole, they both are equal in magnitude, opposite in direction, they both cancels each other. That point P is called null point. In order to calculate that null point, I have to equate the magnetic field inductions due to both the poles M1 and M2 are equal. Now, in order to make them equal, first one mu naught by 4 pi M1 by, what is the distance of M1 from point P? 0.02 minus x whole square, because as per the data given, the distance is given in terms of CGS units, so it has to be converted into SI units, as a 20 centimeters is equal to 0.02 meters. You can see here 0.02 minus x whole square is equal to, the second one, mu naught by 4 pi m2 by x square. By cancelling the like terms on either sides, m1 by 0.02 minus x whole square is equal to m2 by x square. Now, you substitute the values of m1 and m2. m1 is given as 40 by 0.02 minus x whole square is equal to 10 by x square. Cancel these two zeros on either sides. By applying a square root on both sides and on further simplification, you will get the value of x as 0.013 meters. So, the third option is the correct one. Next problem, a bar magnet of magnetic moment 2.5 joules per Tesla is free to rotate in a horizontal plane which is aligned parallel to the magnetic field of induction 0.6 Tesla. Find the work done to rotate it slowly through 60 degrees. The given options are, first one 0.75 joules, second one 0.68 joules, third one 0.45 joules, and the last one 0.36 joules. So, according to the given data, the magnetic moment of the magnet is 2.5 joules per Tesla is given. It is free to rotate in a horizontal plane aligned parallel to the magnetic field of induction 0.6 Tesla. Magnetic induction is given as 0.6 Tesla. You are asked to calculate the work done to rotate it slowly through 60 degrees. That is, theta 2 is given as 60 degrees. So, obviously, theta 1 will be 0 degrees. You are asked to calculate work done in rotating the magnet. The formula for work done in rotating a magnet in a magnetic field is W is equal to minus MB cos theta 2 minus cos theta 1, that is minus M is given as 2.5, induction B is 0.6 cos 60 degrees minus cos 0, that is minus 2.5 into 0.6 into the value of cos 60 is 1 by 2 minus the value of cos 0 is 1, that is minus 2.5 into 0.6 into minus 1 by 2. When you simplify that, you will get the option answer as 0.75 joules. So, the first option is correct one. The next problem, the magnetic induction due to a dipole at a point on the axis which is 0.5 meters from its center is given as 2 10 power minus 3 Weber per meter square. You were asked to calculate the dipole of the magnet, dipole moment of the magnet. The given options are, first one 0.165 ampere meter square, second one 0.175 ampere meter square, third one 0.145 ampere meter square, and the last option is given as 0.125 ampere meter square. So, according to the data, the magnetic induction B is given as 2 10 power minus 5 Weber per meter square. You are asked to calculate the magnetic dipole moment, and further the distance is given as 0.5 meters. Now, calculate the dipole moment. So, the value of capital M you are asked to calculate. The formula for magnetic induction due to magnetic dipole is B is equal to mu naught by 4 pi m by d cube. You are asked to calculate dipole moment. So, from this take out m is equal to B into d cube by 2, this is 2m into 4 pi by mu naught. Now, substitute the values. B induction is given as 2 10 power minus 3, D is given as 0.5. So, d cube is 0.5 whole cube by 2 into 4 into the value of mu naught is this is 4 pi in the numerator, by denominator mu naught value 4 pi 10 power minus 7 Henry per meter. You can cancel this 2 in numerator and denominator, and 4 pi also cancels. After simplification, you will get 0.125 ampere meter square. So, the last one, fourth option, is the correct one. The next problem, the magnetic induction due to a magnetic dipole at a point which is equidistant from two poles is 2.5 10 to the power minus 5 Weber per meter square. If the magnetic moment of that magnet is 20 ampere meter square, you are asked to calculate the distance of the magnet from its center. The given options are: first one 0.525 meters, second one 0.43 meters, third one 0.54 meters, the last one none of these options. The formula for magnetic induction due to a magnetic dipole is B is equal to mu naught by 4 pi m by d cube. In this problem, the magnetic induction is given, the magnetic moment is given, you are asked to calculate the distance. So, from this I can write d cube is equal to mu naught by 4 pi m by b. As we want the distance d, applying a cube root on both sides, we get d is equal to mu naught by 4 pi m by b whole to the power 1 by 3. So, substitute the values. D is equal to mu naught, which is 4 pi 10 power minus 7 by 4 pi. The magnetic induction is given as 2.5 10 power minus 5 magnetic, excuse me, the magnetic moment is given as 20 ampere meter square by magnetic induction, which is 2.5 10 power minus 5 whole to the power 1 by 3. When you simplify this, you will get the distance as 0.43 meters. So, this second option is the correct one. Next problem, the magnetic moment of a magnet is 2 ampere meter square. What is the magnetic induction at a point 50 centimeters from the center of the magnet, which makes an angle 45 degrees with the axis of the magnet? The given options are first one 3.45 10 power minus 5 Weber per meter square. Second option 6.54 10 power minus 7 Weber per meter square. The third option is given as 2.53 into 10 power minus 7 Weber per meter square. Last, none. Now, according to the given data, the magnetic moment of the magnet is 2 ampere meter square. So, given magnetic moment as 2 ampere meter square, the distance is given as 50 centimeters, which is equivalent to 0.5 meters, and moreover the angle theta is given as 45 degrees. What is the magnetic induction? The value of induction you are asked to calculate. The formula for magnetic induction in this case is B is equal to mu naught by 4 pi m by d cube into under root 3 cos square theta plus 1. From this mu naught, its value is 4 pi 10 power minus 7 by 4 pi into m by d cube. 2 by d cube is 0.5 whole cube under root 3 cos square theta is given as 45 degrees plus 1. So, cancel 4 pi, you are left with 2 by 0.5 whole cube into 10 power minus 7 into 3 into the value of cos 45 1 by root 2. So, 1 by root 2 whole square is 1 by 2 plus 1. Okay. When you simplify this, you will get 2.53 10 power minus 7 Weber per meter square. So, this third option is the correct one. Next problem, a bar magnet of length 0.2 meters which is placed in a uniform magnetic field of induction 15 Tesla with its axis making an angle 30 degrees to the magnetic field, which experiences a couple of 7.5 Newton meter. You are asked to calculate the pole strength of the magnet. The given options are first one 4 ampere meter, second one 8 ampere meter, third one 5 ampere meter, the last one 10 ampere meter. So, look at the solution then. So, according to the given data, the magnetic length of the magnet, that is 2L, is given as 0.2 meters. Magnetic field is given as magnetic field induction B is given as 15 Tesla, which is making an angle theta is given as 30 degrees, and the couple is also given, tau is 7.5 Newton meter. You are asked to calculate small m, the pole strength of the magnet. Now, the formula for couple, tau is equal to mb sin theta. From this, torque tau is equal to, here capital M is magnetic moment, which is the product of pole strength and the length of the magnet. So, into b sin theta. As you are asked to calculate the pole strength, take small m from that, tau by 2L into b sin theta. From this, pole strength small m is equal to, substitute the values, tau is 7.5 by magnetic length, it is given as 0.2 meters. The magnetic induction is 15 Tesla into sine, angle is given as 30 degrees, that is 7.5 by 0.2 into 15 into the value of sine 30 is 1 by 2. When you simplify that, you will get it as 5 ampere meter. So, the third option is the correct one. Problem: a bar magnet of magnetic length 10 centimeters and having a pole strength 2 ampere meter is making an angle 60 degrees with a uniform magnetic field of induction 50 Tesla. You are asked to calculate the torque acting on the coil, torque acting on the magnet. The given options are A 4.64 Newton meter, second option 6.48 Newton meter, the third option 8.46 Newton meter, the last one 8.66 Newton meter. Now, the solution: according to the given data, length is given, that is 2L is given as 10 centimeters, which is equivalent to 0.1 meter. Then pole strength is given, small m, as 2 ampere meter. The value of theta is given as 60 degrees. The magnetic induction is also given as 50 Tesla. You are asked to calculate the torque acting on the magnet. The formula for torque is again C is equal to mb sin theta, that is, this capital M is magnetic moment, which is the product of pole strength and magnetic length into b sin theta. You can directly substitute the values. The value of pole strength is given as 2 into the magnetic length as 0.1. The induction is given as 50 into sine 60, that is 2 0.1 50 into sine 60 root 3 by 2. So, if you simplify that, taking the value of root 3 as 1.732, you will get 8.66 Newton meter. So, the fourth option is the correct one. Problem: the ratio of magnetic moments of two bar magnets is given as 4:5. If the deflection due to the first bar magnet is 45 degrees in DMM, that is a deflection magnetometer, you are asked to find the deflection due to second bar magnet. The given options are A tan inverse 2.4, B tan inverse 1.4 C, tan inverse 1.2 D, tan inverse 2.6. Here ratio of magnetic moments on DMM. What is the formula for ratio of magnetic moments of 2 bar magnets in DMM? The formula is M1 by M2 is equal to tan theta 1 by tan theta 2. We will come across this relation for DMM by equal distance method to compare the magnetic moments of the given 2 bar magnets. Given the ratio of magnetic moments as 4:5. Moreover, the deflection due to first bar magnet theta 1 is given as 45 degrees. The deflection due to second one you are asked to calculate. Now, M1 by M2 is equal to tan theta 1 by tan theta 2. That is, therefore, M1 by M2 4:5 is equal to tan theta 1, that is 45 degrees by tan theta 2, that is 4 by 5 is equal to the value of tan 45 is 1 by tan theta 2. From this, if you cross multiply tan theta 2 as 5 by 4, that is 1.25 by applying a tan inverse on both sides. Therefore, theta 2 is equal to tan inverse 1.25. So, tan inverse 1.2, this is third option is correct one. I am repeating the problem once again. The ratio of magnetic moments of the given 2 bar magnets is 4:5. If the deflection magnetometer if the deflection produced due to first bar magnet is 45 degrees in the DMM, you are asked to calculate the deflection due to second bar magnet. In DMM by equal distance method, the formula to calculate the ratio of magnetic moments is M1 by M2 is equal to tan theta 1 by tan theta 2. As per the given data, M1 by M2 is given as 4:5, theta 1 is given as 45 degrees, you are asked to find the value of theta 2. By substituting the values in this, 4 by 5 is equal to tan 45 by tan theta 2, as the value of tan 45 is 1, 4 by 5 is equal to 1 by tan theta 2, from the tan theta 2 is equal to 1.25, by applying a tan inverse on both sides, we get a theta 2 as a tan inverse 1.25. So, this third option is correct one. Next problem, if a bar magnet of magnetic moment of inertia 1 10 power minus 2 kg meter square vibrates in a magnetic field of induction 0.36 10 power minus 4 Tesla, the time period of vibrations of the magnet in the DMM is given as 10 seconds. You are asked to calculate magnetic moment. The given options are: first one 10 ampere meter square, second one 11 ampere meter square, next 9 ampere meter square, first one 6 ampere meter square. The solution then: given moment of inertia is I, is given as 1 10 power minus 2 kg meter square. The magnetic field of induction B is given 0.36 10 power minus 4 Tesla. The time period of oscillation is also given as 10 seconds. You are asked to calculate magnetic moment of the magnet. Here, this problem is based on the concept of vibration magnetometer. The formula to calculate the time period of a magnet which is placed in the vibration magnetometer is T is equal to 2 pi under root I by mb. Here I is moment of inertia, capital M is magnetic moment, and B is magnetic field induction. What you are asked to calculate? You are asked to calculate magnetic moment. Capital M we have to calculate. So, for that according to my convenience, I am simplifying this equation by applying square root on both sides. I get a t square is equal to 4 pi square I by m into b. You are asked to calculate magnetic moment. So, take m outside from that. From that magnetic moment, m is equal to 4 pi square by t square into I by b, that is 4 pi square, the value of pi is 3.14 whole square by time period. The time period of oscillation is given as 10. So, 10 square into the moment of inertia of the magnet is 1 into 10 power minus 2 by induction B. Its value is given as 0.36 10 power minus 4. When you simplify, finally you will get the magnetic moment as 11 ampere meter square. So, second option is correct one. I am repeating the problem once again. A bar magnet of moment of inertia 1 10 power minus 2 kg meter square. It is vibrating in a magnetic field of induction 0.36 10 power minus 4 Tesla. The time period of oscillation is 10 seconds. You are asked to calculate the magnetic moment of the magnet. So, those are the 4 options given there. As I told you already that this is the problem based on the concept of the time period of oscillation for a given magnet which is placed in the vibration magnetometer. The formula for time period is 2 pi under root I by mb, where I is moment of inertia, capital M is magnetic moment of the magnet, and B is magnetic field induction. So, according to the problem given, the moment of inertia is 1 10 power minus 2 kg meter square. The magnetic field induction is 0.36 or 10 power minus 4 Tesla. The time period is given as 2 seconds. So, substituting all the data in this relation by simplifying, you will get the magnetic moment of that magnet placed in the vibration magnetometer as 11 ampere meter square. So, the second option is correct one. Next problem, two short bar magnets having magnetic moments in the ratio 27:8, they are placed on the opposite sides of a DMM, that is a deflection magnetometer, which is basically a device that is used to compare the magnetic moments of the given two bar magnets. DMM. Find the distance of the stronger magnet if the weaker magnet is at a distance of 10 centimeters from the center of the DMM. As I told you already that this DMM, by using this DMM, the magnetic moments of the given two bar magnets can be compared. These magnetic moments can be compared in two methods. One is equal distance method, another one is null deflection method. The ratio of magnetic moments obtained by using these two methods are approximately equal. Okay. Now, this is the problem based on equal the distance null deflection method. So, the ratio of magnetic moments is given, one distance is given, another distance you are asked to calculate, null deflection method. By using null deflection method, okay, before that look at the options. The first option is 5 centimeters, second option is 10 centimeters given, third option is 15 centimeters, and fourth option is 20 centimeters. Now look at the solution. By null deflection method, the formula to calculate the magnetic moments of the given two bar magnets is m1 by m2 is equal to d1 cube by d2 cube. This is the formula. Given the ratio of magnetic moments m1 by m2 is given as 27:8. Find the distance of stronger one if the weaker one is at a distance of 10 centimeters, he said. So, let d2 is 10 centimeters. From this it is equivalent to d2 is 0.1 meters. The value of d1 you are asked to calculate. Substitute that data in this relation. Therefore, 27:8 is equal to d1 cube by d2 cube. From this, d1 cube is equal to 27 into 0.1 whole cube by 8. You simplify that, you will get the value of d1 as 0.15 meters. That 0.15 meters is equivalent to d1 is equal to 15 centimeters. So, this third option is correct one. Repeating the problem once again. Two short bar magnets having the magnetic moments in the ratio 27:8. They are placed on the opposite sides of a deflection magnetometer. Find the distance of the stronger magnet if the weaker magnet is at a distance of 10 centimeters from the center of the DMM. As it is based on the concept of null deflection method, we know that by using null deflection method, the formula to calculate the formula to compare the magnetic moments of the given two bar magnets as m1 by m2 is equal to d1 cube by d2 cube. According to the data given, m1 by m2 is 27/8. Let the value of d2 is 10, which is equal to 2.1 meters. As you are asked to calculate d1, by substituting the data in this relation, by simplifying you are getting the value of d1 as 15 centimeters. So, third option is correct one.